So this is a talk on simulator theory. If you were here for a presentation yesterday, this is basically the same thing, but a little bit shortened and sped up. So apologies for the repetition. But anyway, simulator theory is a way of understanding what artificial intelligence is. This is in contrast to, say, the tool narrative promoted by AI labs, whereas like you use it a chatbot, it gives you answers, that kind of thing. And basically, our understanding of a tool is it's used by something else, but doesn't really describe the thing itself. It's rather the relationship between an entity and a user. So a bit of a red herring in terms of like understanding what a particular AI system is. Then there are agents. This is the narrative typically promoted by alignment literature. And what is an agent? Well, you see, one property is it's goal-directed, which means its behavior can be compressed into its consequences. And also instrumentality seems pretty important for agency. An example of something that tends to create agency is reinforcement learning. It optimizes a reward function, so like that kind of pushes towards goals. And also the time delay gives it reason to develop instrumentality. Simulators, in contrast, is when the behavior is dependent on a process rather than a particular end. Although one consequence of this is if the process being simulated has agents in it, then those would get simulated. And in the context of LLMs, we call these simulacra. Self-supervised learning, in particular, seems to create AI of a simulator nature. Largely because it seems to have no intermediate goals. So when you're predicting the next token, you have a loss from that. The feedback is pretty immediate, and so there isn't really much need to develop instrumentality there. Although there's a little bit of a caveat here in some cases, like rhyming poems. There is some reason to look ahead, and which has been seen, but this is still fairly minor. So these are the concepts in their pure forms. They can also overlap. So one overlap of interest is between agents and tools. And these are like partially orthogonal in that they can exist independently, but there's a little bit of tension between them. And so we can see that in the types of like agent tool combinations that can exist. So if you imagine entity A is a principal and B, the user, and B is the thing being used, if they both happen to want the same thing, their relationship is one of collaboration. If they want different things, but B does what A wants anyway, it's a slave relationship. And if what B wants is just a pointer to what A wants, then that's corrigible alignment. We can also see a little bit of tension in terms of as the agency of the tool goes up, the resolution of control of the user goes down. So for example, if I'm building a house, then if I manage the hammer and nails and everything else, then I have a lot of control over every little step and every detail. Whereas if I hire a team of builders, there's a lot less control, but I still get the big picture. With agents and simulators, the tension comes in the form of which is driving the bus, as it were. So on the one hand, you could imagine a agent simulating the environment and understanding its world so that it can navigate it better. But on the other hand, simulators, as I've mentioned before, might generate agents as part of their simulation, in which case, and then we would expect different types of goals from each of these, where the agent's using the simulator, the goals that it has is what's driving its behavior. Whereas if it's created in the context of the simulation, then the simulation is what's shaping its motivations and behavior to serve that simulation. We could also see this in a hybrid sort of form where it's hard to tell which the system is. So maybe it looks kind of simulatory in general, but is guided towards particular types of outcomes. So looking at the alignment implications for each of these, for tools, basically the things we're concerned about is empowering bad actors, mistakes, that sort of thing. Not really the tool. The tool just amplifies the operator's behavior. For agents, this is classic like alignment kind of stuff. The agent's actions depend on the end goal, so you better hope that's a good end goal. And then what are the right end goals? For simulators, this is kind of intermediate. So if tools were pretty optimistic view of alignment and agents are a pessimistic view of simulators are kind of in between, we see them as being about as aligned as the characters that they're simulating. So then the question is, well, are you going to get a good or a bad character? And so example of a bad character is what is known as the Waluigi effect. So if you remember like some things like Bing Sydney, where it occasionally like harass its users or just go off the rails. That's kind of the Waluigi effect in action. And this, where we kind of suspect that this comes from, is that specifying a character mostly specifies its opposite. You just have to change a few key characteristics, but most of the work is done. And then a specific type of Waluigi is one that's deceptive, where if you take any conversation, you could interpret that as following rules, or it could also be understood as like pretending to follow rules, but really secretly doesn't want to. Looking at this can have some large implications. Uh, so you can imagine if you had a misaligned AI and in a very powerful position, rather than this being this ruthless optimizer that like inevitably destroys the world, you might get a science fiction style supervillain who's basically acting the part of a rogue AI like out of movies, and get like this really catastrophic but non-existential sort of event. It also kind of amusing to imagine that if this happened and you weren't able to just turn it off or switch it out easily, then we might try to redirect it by convincing it that it's on a redemption arc or something like that. And so you'd have to get people who really understand like the little nuances of language that would guide it in that direction. Because simply saying like stop doing this, well, that's a supervillain wouldn't respond to that. So like you have to actually play to it. Uh, so those are some of the big concepts. How might we actually test for any of this? So interpretability is pretty difficult here. One, because these are high level concepts, and second, because the concepts overlap a lot, and so it's kind of really difficult to judge. But one a theory that we have is that early training is going to mostly set the early weights. It's going to set the early circuits early on, which then get fixed as they build dependencies later on in the network. And therefore, most post-training will mostly change the final layers. And so where we see currently of the self-supervised learning has the bulk of initial training that we'd expect that to more or less lock a simulator in place in the earlier layers. And then the later training, RLHF or other like agentic creating kinds of methods will put more agentic type circuits towards the end. So we'd see like this simulation, which then creates decisions at the end. So like an agent using a simulator. So then just taking all this and practicing it a little bit, I'm going to skip over these slides for time, is so emergent misalignment. This seems like very well explained by something like the Waluigi effects and fits with the simulator lens pretty well. Whereas on the other hand, something like chain of thought monitoring, AI seems to just want the reward and willing to hack for it. Trying to add a simulator lens to this is just saying, well, maybe it generated the type of character that wanted to reward hack. It's a bit of an epicycle, unnecessary explanation. We had a couple other examples in the longer presentation, not enough to really draw a strong conclusion, but it kind of seems that like chain of thought seems to be used in more agentic examples, whereas the more simulatory examples were were closer to self-supervised learning. So ending with our predictions and recommendations going forward is that the recent models that are mostly based on self-supervised learning, like chatbots essentially, have been relatively safe and actually probably would continue to be so if only scale was applied. And safe, I put a big asterisk here, at least from optimizers, at least, probably a lot of looseness here. However, it probably doesn't matter because agency is likely coming back with OpenAI applying the year of agents and trying to move things in that direction for economic sorts of reasons. And this leads to our conclusion that the safety tax, or things you have to avoid to keep AI safe, is not avoidable, but maybe reducible. In the words of Jan LeCun, or paraphrase of it, we just need to build the safe AIs and not build the unsafe ones. However, this requires being able to divide AI up enough to be able to know the difference and to have these kind of different categories, to be able to have lines between them and admit the fuzziness of those lines, and then act on it. So if there are categories that are not safe, and to not make those, even if it's profitable to do so. And that is it for our talk. We'll be publishing a series of essays on Less Wrong later, and eventually they'll be recording the longer version.